Hello, welcome to episode 8D. We're going to be looking at drag motion once again. And this time we're going to be solving, so suppose we had our function and we throw it up in the air and it lands somewhere here. We want to know how far it travels, right? So we have this equation and I'm going to use this simplification. So y naught is equal to x naught, which is going to be equal to 0 since we start at our origin, right? So how do we go about this? So when we substitute this in, yx is equal to tau vt. I'm actually going to put the linear term at front, t over vox x plus tau vt natural log of 1 minus x over vox. And this is going to be, it's a root, so our y equals 0. So we want this to be equal to 0. So we want to solve for x. So how can we do this? Because if you notice, we have a log term and a linear term. And this isn't really nice. It turns out actually that this is not analytic. So we cannot use algebra to just simplify this. So we're going to have to use some sort of approximation. So what we can actually do is we can use the Taylor series, or at least the Taylor polynomial of the natural log of 1 minus some epsilon. So we do natural log 1 minus some epsilon is approximately negative epsilon minus negative epsilon squared over 2 minus dot, 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 whatever that is. We don't care. We're going to cut this off at 2 for now. So let's substitute that in. Y of x equals voy plus vt over vox x minus tau vt x over vox minus tau vt x squared over 2 vox squared. And now we have a quadratic. Hooray! So you might want to think, okay, well, we can use the quadratic formula to solve this. And if you wanted to, yes. However, there's another simplification. Both sides have x. There's no c, so c equals 0. So we can actually remove divide by x. And so when you do that, what do we get? Well, first let's simplify this equation a little bit. It's going to be voy plus 1 minus tau v terminal. So we put this in on the inside over vox times x minus tau v terminal over 2 vox squared, x squared equals 0. Minus. So I'm going to divide by x here. Divide by x. It's going to cancel. And I'm going to multiply by vox on both sides. And I'm going to add this to the other side. So we're going to end up with voy plus 1 minus tau v terminal over tau vt times 2 vox is equal to x. And this is going to be our other route. So that's the distance that it travels. And remember, tau is this constant, which is our mass over our linear coefficient, right? So hopefully that makes sense. Let me know if there's anything missing. We can obviously use that to compare with other values and such. But yeah, so that we just solved for the distance traveled with linear drag. So in the next video, we're going to actually talk about quadratic drag and how to derive these equations of motion for quadratic drag. Because quadratic drag is often a bit more useful because often objects are moving fast enough and are large enough where this is more important. All right, see you then.